this video, we're going to talk about zero and negative exponents. In the video before this, we were working with positive exponents, and we came up with some rules that we can apply to them in order to simplify them. But now our question is, what if we have a negative exponent, or what if we use zero as an exponent? So I'd like to explore that idea in this chart by completing what we should already know, and then using some logic to try to come up with what we don't know. So 10 to the first power means that we just have a single 10. So 10 to the first power equals 10. 10 squared means that we're being asked to do 10 times 10, and 10 times 10 is 100. And the reason I picked 10s is because they're just so easy to work out. Because 10 cubed, which is 10 times 10 times 10, it really has to do with how many zeros we have, which there are 3 of them, so it ends up being 1,000. And we could continue this chart on really easily, either by thinking about how many zeros there are, or now that we've got these listed, we might be able to see a pattern. For instance, to go from 10 to 100, we could think of it like we added a 0. To get from 100 to 1,000, we added a 0. So to get from 1,000 to our next number, we should add another 0, making this 10,000. So it would be easy for us to continue to the right. What we want to do is think about what to do to continue to the left. So to think about 10 to the 0, I want to actually look for a pattern backwards. I want to think, how do I get from 1,000 to 100? An easy way to think about it is that we have one less 0 written in our problem. We still have the 1 on the far left, but we took out a 0 to go from 1,000 to 100. If I go from 100 to 10, the same thing happened. We still have a 1, but we have one less 0. So if I try to apply that same situation to 10 to the 0, if I take a 0 away from 10, I'm left with just the number 1. So 10 to the 0 power, we've just discovered, should be 1 in order for this pattern to make sense. And that actually is true. 10 to the 0 power is 1, and in fact, anything to the 0 power is 1. So down here in this chart I can say that 7 to the 0, as an example, is 1, or I can also say that x to the 0 is 1, and this x, we are trying to represent anything as 0, and that equals 1. So then the question becomes, what happens if I keep going? Because we're out of zeros to put in, or to get rid of, and so how does that work? Well, another way of thinking about what we did, if we take a 0 away from something in this manner, it's like we're dividing by 10. 1,000 divided by 10 is 100. And 100, if I divide that by 10, gives me 10. And 10, if I divide it by 10, gives me 1. So the question is, what is 1 whenever I divide it by 10? There's two different ways that we could write that. We could write it either as a decimal or a fraction, but it's going to be more helpful for us to write this as a fraction because in general on our problems, we are going to want to write them as fractions. So 10 to the negative first power ends up being 1 over 10, which we could think about that bottom number as if it was to the first power. What happens if I do 1/10 divided by 10? Now that's quite a bit trickier at first. The way we would go about solving that is we would actually make the 10 be a fraction and flip it so that we can multiply by the reciprocal. And so we get 1 over 100 when we divide 1/10 by 10. Think about it that we're dividing, so we should be getting a smaller fraction. So it would make the bottom be a bigger number. Another way to write 1 over 100 though is to write 1 over 10 squared. If we try this with 10 to the negative 3, if I divide 1 over 100 by 10, it should make the bottom number be bigger. It should add a 0 to the bottom number. This would be 1 over 1,000. Or another way to think of it is 1 over 10 to the third power. I'm not sure what button I'm pressing that is advancing my slides, but I'm going to try to stop pressing it. So if I look at what I have up here, 10 to the negative first turned into 1 over 10 to the first, 10 to the negative 2 turned into 1 over 10 squared, 10 to the negative third turned into 1 over 10 cubed. It turns out that negative exponents are telling us that we have whatever that is on the bottom of a fraction. So 3 to the negative third, for instance, would actually end up being 1 over 3 to the third. We can figure out what 3 to the third is because it's 3 times 3, which is 9, times another 3, which is 27. So the answer to this is 1 over 27. In contrast, if we had a negative exponent on the bottom, well, we could make that be on the bottom of another fraction, but really what we would be doing is moving it to the top of our fraction, and that would give us a positive exponent. So we'd change the 4 to the negative 2 so that it is 4 squared on the top, which gives us 16, and the over 1 isn't really necessary. So our rule is that if I have a negative exponent, I'm going to put it on the bottom of a fraction. If it's just a normal number to start off with, or a normal variable to start off with. If I start off with something on the bottom of a fraction, I'm instead going to move it up so that it's not a fraction anymore. Our answers are going to contain positive exponents. That's one of the ways that you'll know that you're finished, is that all of your problems, all of your numbers, your exponents, whatever you call them, all of your exponents should be positive, and that helps you know that you're done. So let's look at example 1. We are asked to simplify. We're reminded our answer should contain only positive exponents. So the only thing to do on this problem, 7n to the negative 2, is to fix the fact that this is a negative exponent. Now, it can be really tricky. A lot of students will also move the 7 down to the bottom. But remember that normal numbers do have their own exponents. This is 7 to the first power, and that's a positive exponent. The negative 2 is only applying to the n. If we had parentheses like this, that would be a different problem. Then we would give the 7 the negative 2. But since that's not what's happening, the 7 gets to stay where it's at, which is on the top of a fraction. The n is what needs to move down to the bottom. Anything we have in math that's not already a fraction, we can make a fraction just by putting it over 1. So the n is going to move down, but the 7 is going to stay on top, so that this becomes 7 over n squared. And that's our answer. On B, it says k to the 0 power. Well, anything to the 0 power is 1. So that means that our answer is just 1. And that's going to be really helpful on problems. Anytime you see a to the 0 power, that's something that you should try to deal with first. It may not be that that's the only part of the problem. It may be mixed in with some other things, but it will make it easier if you go ahead and account for the fact that anything to the 0 is 1 before you mess with anything else. On C, we also have a situation where we have a negative exponent to move down to the bottom and a positive exponent that needs to stay on top. So we'll keep the b to the fourth on top, and we'll move the a to the negative third down to the bottom, and that's going to make it have a positive exponent on the bottom. Now let's mix in some of our rules from 8.1, our previous video. If I have a situation like this, 3x cubed times x to the negative 2, my normal number here, 3, doesn't have any other normal numbers that will affect it, so we should definitely have a 3 in our answer. From there, we have these two x's that have the same base, and so since there's no parentheses, we need to add their exponents together like we did in the previous section. 3 plus negative 2 is 1, so we get x to the first power, and since it's to the first power, we don't need to write down the 1 as the exponent. On part B, we've got a couple things we can do to start off here, or one thing that we need to do to start off here. V to the 0 is 1, and so this is not going to affect the rest of our problem at all. And now our problem is going to look a lot like A did. The 2, again, doesn't have anything that it needs to interact with. The V's, we need to add their exponents together to combine them into a single V. Negative 5 plus 2 is negative 3. Now we're not done with this because we have a negative exponent. Now it's like our problems on the previous example. So I need to move this down to the bottom. The 2 stays where it's at. It has a positive exponent of 1. And V moves down to the bottom and becomes V cubed. So our answer here is 2 over V cubed. Now C looks quite complicated because we've got so many different things that we're trying to put together. So let's break it down into 3 different parts. Let's first start with the normal numbers, 5, 2, and 7. 5 times 2 times 7, since those are normal numbers, it's normal multiplication, that gives me the number 70. And once I've done that, if it makes it seem like less effort, you can mark those out, and then we know that we don't need to use those numbers again. Now let's look at the r's. We have r squared, r to the fourth, and r to the negative third. Since they're all r's, we just need to add their exponents together to write them as a single r. So 2 plus 4 plus negative 3 is 6 plus negative 3, which is 3. So that's it for the r's. Now, all I have left are q's. I probably don't even need to rewrite the q's. I need to add their exponents together. Negative 4 plus negative 1 is negative 5. Negative 5 plus negative 7 is negative 12. So q to negative 12. We do have to be really, really careful to remember our negative and positive rules from earlier in the year. Now, we're not done because we have a negative exponent to move down to the bottom. The 70 and the r cubed get to stay up top, but the q needs to move down to the bottom. And we can't do any other sort of simplification. Our exponents don't simplify together if they are different bases, and our normal number can't simplify with the exponents. They don't interact that way. So that's our answer for that problem. Now let's look at our other rule from the last video, where when we have parentheses, we're raising a power to another power. That made us multiply our exponents. So here we need to do negative 2 times negative 3. A negative number times a negative number is a positive, so we get a to the positive 6. And since it's a positive exponent, we don't have to do anything else. On B and C, there's actually more than one way to do it, so I'm going to show you one way, and if you think that you know another way to do it, if you get the same answer as me, then you've probably done it the right way. Starting kind of in this section, and definitely in the next one you would do after this, you can do things more than one way and get the same answer, and that's okay. I'm only going to show this one way because I don't want to confuse people who are just looking for the bare minimum way to understand how to do this. But in a future video, I'll probably talk about the other way that we could do these problems. So remember that the 2 matters, that it's not squared just because the k is squared. The 2 needs the negative 5th power, and the k squared needs the negative 5th power. So 2 needs the negative 5th, and k squared needs the negative 5th. Now, 2 to the negative 5th, I don't know maybe right off the top of my head, but I know I'm going to need to move it down to the bottom. And actually it'd be easier if I went ahead and wrote this as 2 times negative 5, which is negative 10. So both of these have negative exponents this time. They both need to move down to the bottom. We actually haven't had that happen yet on an example problem. If they both move down to the bottom, we have to make sure to put a 1 on top to show that they are truly on the bottom of a fraction. If we don't put the 1 on top, it just looks like we have 2 to the 5th and k to the 10th not on the bottom of a fraction, and that's not right. Now 2 to the 5th is 2 times 2 times 2 times 2 times 2, which timesing by 2 isn't super difficult. If you need to write it down, that can be super helpful, as it always is in math. This part is 4, and this part is 4, and 4 times 4 is 16, and 16 times 2 is 32. So our answer here is 1 over 32 k to the 10th. This last one gets a little bit more complicated because look, we've got a negative right here. So the most important thing on this problem and to understand about regular negatives is this negative does not interact with either of these negatives. They are completely separate things. And so the negative in front there, we're going to have to deal with the way we did on the previous video. So here's what I mean. The negative 4th power needs to go to the negative 3, to the y to the negative 6, and to the z squared. So negative 3 is raised to the negative 4th power. It's easiest really to think of this together as negative 3, although there is a way you could just think about a negative to the negative 4th power and get the right answer. Then we want to do y to the negative 6th to the negative 4th. Negative 6 times negative 4 is 24. And then we want to do z squared to the negative 4th power, which gives us a negative 8. So there are 2 things we're going to have to move down to the bottom. This moves down to the bottom, and this moves down to the bottom. So it leaves us with y to the 24th on top. And when we move it down to the bottom, that's why our exponent becomes positive, but we still have a negative inside of our parentheses that we'll deal with in a second. And the z to the 8th, the 8th becomes positive. So our question now is, what is negative 3 multiplied together 4 times? And again, it's easiest to write it out and group them. So this is positive 9, this is positive 9, 9 times 9 is 81. It turns out the negative did go away, but that has to do with the fact that we were raising it to an even power and not that we were raising it to a negative power. If this had been to the negative 3rd power or the negative 5th power or even the negative 1 power, we still would have ended up with a negative in our answer because it would have an odd number of negatives. This can be really confusing, especially the first time you go through it. It will get better the more you do it, or even when you revisit it in Algebra 2, it should be easier. But the important thing right now for you to do to be successful is just to practice as many problems as you can, checking your answers so that you know if you're doing it right or wrong. If you like this video, please hit the thumbs up and feel free to check out other videos. I've suggested one somewhere on the screen. If you want to know when I post new videos, hit the subscribe button, and you can also follow me on Twitter at KSteveMath. If you have a math question that I haven't answered, tweet me a picture and I'll try to answer it. Thanks for watching!